And as long as you know how to do what we just did, you're going to be fine for this. Even if you don't know how to do what we just did, this is going to help teach you that process. And so we start with the unit circle. The unit circle is a circle with radius 1. We've already talked about that, right? And when we're in the unit circle, we have these special coordinates right here. What is that? What is that point right there? One, 0. What's this coordinate right there? 0, 1. Back here. -1, 0. 0, -1. Okay, so we're in that unit circle. And there's certain things that we want to find. Now, in math, we can always show you why something is the way it is. But today is a little bit different. We're going to actually define terms. So, for example, the other day we said that if you had a 30, 60, 90, where this was 10 and this was 5 and the other side was 5 roots of 3. I could show you why this always ends up to be 5 roots of 3. I'm going to tell you what sine is in this scenario, and it's a definition. There's no why, it's just we've defined it to be this. Kind of like an alligator is something with big teeth and really long, and yeah. We're defining something to be what it is. Sine of theta. If you have an angle, okay, so I'm going to draw an angle. We're going to call it theta. It crosses through a certain coordinate. And we call that coordinate x, y. It's the terminal point. We've worked on finding those, haven't we? And we're good at it. Yeah. So once we can find those, we can define these terms. Sine of theta, or sine of the angle, we don't write S-I-N-E, we write S-I-N. And when you see that mathematically, it's not sin. Don't say sin, it's sine. Sin is something we talk about in church. Sine of theta. And what sine of theta is it's the y value of the terminal point divided by the r value. Now here's the cool thing. What is the r value in the unit circle? 1. So y over r would just be y. The second trigonometric function I want to teach you is cosine. You don't write it like that all the time. We write it like this. So you see that? Don't say cos. Don't say cos. We say cosine of theta. And that's equal to the x value divided by r. And if the r value is 1, then it's just x. The third one is tangent of theta. And we write it like this. We don't say tan. That's something you do on the beach. We say tangent of theta. And that's equal to y divided by x. Y divided by x. There's 3 others. We're not going to spend a lot of time talking about these today, but cosecant we write as CSC. That means cosecant. And it's the reciprocal of sine. It's 1 over sine of theta. And then we have secant. We write that as SEC of theta. And that's 1 over cosine. And then finally, cotangent, we write as COT, cotangent of theta, and that's 1 divided by tangent. Not too bad? Okay, so here's what we're going to do. We're going to calculate the exact values of sine, cosine, and tangent for the given values of theta. So I'm going to give you an angle, and you determine the terminal point based off of the work that we just did in class when you entered. I look at pi over 6. Somebody tell me how many degrees is pi over 6? 30 degrees. So I sketched the triangle, just like so. I have a 30-degree angle, I have a 60-degree angle, I have a 90-degree angle. What's the length of the radius? 1. Now what do I do? If it's a 30, 60, 90, what's this side? Half. And then this side is root of 3 over 2, okay? In a 30, 60, 90, you divide the short side, or you divide the hypotenuse in half to get the short side, and you multiply by the root of 3 to get that. So what is my coordinate? So here, so we've already done that before, right? So here's the new piece for today. We're going to determine the sine of pi over 6. The sine of pi over 6, according to my chart, says it's the y value. So the sine of pi over 6 is 1/2. The cosine of pi over 6, my chart says it's the x value. So the cosine of pi over 6 is and then the tangent of pi over 6, how do I calculate that? You take the y value divided by the, okay, let's be careful there. So you have the y value, which is 1/2, and you divide it by the root of 3 over 2. So I'm dividing fractions right now. How do we do that? Multiply by the reciprocal. So I multiply by 2 over the root of 3. What happens? 2's cancel, and I get 1 over the root of 3. Is that my answer? No. Multiply the top and bottom by the root of 3, and you get the root of 3 over 3. That's your answer. Pi over 4 is how many degrees? So therefore, this is negative 45 degrees. Which quadrant does negative 45 degrees place me in? Fourth quadrant. So your angle is going to be right down here. So I don't have a 30, 60, 90 this time. I have a 45, 45, 90 this time. The length of the hypotenuse is always 1. Anybody remember what the length of the other sides will be then? Good. So it used to take us a while to come up with that, didn't it? But now that's like second nature. We know what that is, don't we? And we could just identify the coordinate then. We have root of 2 over 2, and we have root of 2 over 2. True or false? They're both positive. Which one's negative? The y value. Good. You're in the fourth quadrant, so the y value would be negative. So let's identify sine, cosine, and tangent. The sine of negative pi over 4, the cosine of negative pi over 4, and the tangent of negative pi over 4. What's the sine value going to be? The y value, negative root of 2 over 2. What's cosine going to be? And how is it again that I figure out tangent? Yep, I take the y value divided by the x value. So negative root of 2 over 2 divided by root of 2 over 2. If you take something divided by itself, you get 1. So what am I going to get in this situation? Negative 1. I want to show you guys something kind of cool here. If I take out my calculator and I press, if you can see your calculator has a difference between radians and degrees. If I press tangent of negative pi divided by 4, it produces the exact value of negative 1. But watch what happens if you do sine. Sine of negative pi over 4. You can see that you get this. That doesn't look like that, does it? But if you check on your calculator, it comes out negative root of 2 divided by 2. They are the same. If on the test, and usually I have about 3 people who do this, instead of doing this process to coming up with these exact values, they just type in their calculator, they write down the decimals. I don't give you credit for that, okay? That's not the trigonometry. Produce it this way. If you ever want to check on your calculator, go ahead. I can verify it for you. Let's try one more. Flip it over. Pi over 2. 90. Do I need to make a triangle? No. What's the coordinate up there? 0, 1. So therefore, we have the sine of pi over 2, the cosine of pi over 2, and the tangent of pi over 2. What is the sine of pi over 2? It's the y value, 1. What's the cosine? And how do I figure out the tangent? 1 divided by 0. If you have 0 on the top, what's the answer? If 0 is on the bottom, what's the answer? If you ever have a 0 in the denominator, we say undefined. And sure enough, if we try that on our calculator, the tangent of pi over 2, you can see your calculator gets an error in that situation. Can't compute it. Okay? That's the only extension for today, sine, cosine, and tangent. As we move on over the course of the next couple days, you're going to be doing something that you did back in geometry. If you remember, do you ever remember pressing sine of, say, 37 degrees on your calculator? So we're going to be using our calculator to come up with other values later on. So I would highly encourage you to bring your calculator ready to go. Your phone may work for you. Sometimes it doesn't work quite as nicely as a calculator. Take out your worksheet. So yesterday you were producing the unit circle and things like that. You can see that today is very similar to the work you've done. You're just listing the sine, the cosine, and the tangent values after you go ahead and figure out that terminal point. Okay, so the sine, cosine, and tangent values after you figure out the terminal point. This used to be a sheet that I had that was 4 pages. I cut it down to just a front and a back. So you should have time to go over that. You got about 18 minutes here. Sorry, about 12 minutes here. I'll let you guys get going, and I'll come around and help people. Go ahead and work.